Hello and welcome. Today we will be talking about what is the function of a capacitor, how a capacitor works, and what makes up a capacitor. The function of a capacitor is to store and release electrical energy in an electronic circuit. It serves as a temporary energy storage device that can influence the behavior of electrical signals in various ways. Capacitors have a wide range of applications in electronics, and their primary functions include energy storage and release. Capacitors store and release electrical energy for quick bursts, as seen in camera flashes and pulse generators. Filtering. They smooth out power supply voltage fluctuations, ensuring a stable DC voltage output. Timing and delay. Capacitors, along with resistors, create precise time delays in circuits for applications like timers and oscillators. Signal coupling and decoupling. They allow AC signals to pass while blocking DC, coupling audio and RF signals, and decoupling noisy power lines. Tuned circuits. Capacitors work with inductors to create resonant circuits used in radio tuning and filtering. Signal processing. Capacitors are used in filters, tone control, and equalizers to manage signal frequencies. Motor starting. They provide initial power boosts for starting electric motors. Data storage. In flash memory, they store binary data by trapping or releasing charge. Sensor circuits. Capacitors are used to sense and detect changes in capacitance for various environmental factors. A capacitor works by storing electrical energy in an electric field that forms between two conductive plates, which are separated by an insulating material called a dielectric. The process involves the accumulation of electric charge on the plates when a voltage is applied across them and the subsequent discharge of this stored energy when the voltage is removed or changed. Here's a simplified breakdown of how a capacitor works. Charge accumulation. In an uncharged capacitor, both plates have an equal number of electrons, resulting in a neutral overall charge. When a voltage source, such as a battery, is connected to the capacitor, electrons are pushed away from one plate and drawn toward the other. The plate connected to the negative terminal of the voltage source accumulates an excess of electrons and becomes negatively charged. The plate connected to the positive terminal loses electrons and becomes positively charged. Formation of electric field. The accumulation of opposite charges on the plates creates an electric field between them. This electric field represents stored electrical energy. The insulating dielectric material between the plates prevents the direct flow of electrons between them, allowing the electric field to build up. Stored energy. The electric field between the plates stores energy in the form of potential energy. The amount of stored energy is proportional to the square of the voltage applied and the capacitance of the capacitor, a measure of its ability to store charge. Discharge process. When the voltage source is disconnected, but the capacitor is still connected to a circuit, the stored energy in the electric field remains. Electrons flow from the negatively charged plate to the positively charged plate, creating a brief current. This discharge process causes the voltage across the capacitor to drop over time. Equilibrium. As electrons flow, the charges on the plates gradually equalize, and the voltage across the capacitor decreases to zero. Once the charges on the plates have balanced, the electric field between the plates dissipates, and the capacitor is fully discharged. In summary, a capacitor works by storing electrical energy in the form of separated charges on its plates and the resulting electric field. A capacitor consists of conductive plates, usually metal, separated by an insulating material called a dielectric. This setup allows the capacitor to store electrical energy in the form of charges on the plates while preventing direct contact between them. The conductive plates are connected to terminals or lead wires for circuit connection. Capacitors store energy by accumulating opposite charges on the plates, and the dielectric material maintains the charge separation. The ability of a capacitor to store charge, known as capacitance, depends on factors like plate area, plate distance, and dielectric properties. Different types of capacitors vary in construction, size, and dielectric material, adapting them for diverse electronic applications. Thanks for watching.